All right, let's talk about Docker. You've probably heard the name, and maybe you've heard developers joke about the classic excuse, but it works on my machine. Well, Docker is the tool that pretty much put an end to that problem. Today, we're going to pull back the curtain and break down exactly what it is and how it works, piece by piece. So here's our game plan. We'll start with the big question. What even is a container? Then we'll look at the blueprints used to build them. After that, we'll see the whole process from your code to a live running container. We'll also tackle how these containers talk to the world and save data. And finally, we'll level up to managing a bunch of them at once and wrap it all up with some pro tips.
Okay, let's dive right in. First things first, we've got to tackle the biggest question head on. What exactly is a container? I mean, really, because this is the foundation for everything else we're going to talk about.
You've probably heard of virtual machines, or VMs, right? Think of a VM like building a whole separate house for every single guest. Each one needs its own foundation, plumbing, electricity, a full operating system. It's heavy, it's clunky, and it takes minutes to get going. Now look at containers. They're more like renting out rooms in one big apartment building. Everyone shares the main infrastructure, the host OS, but they each have their own private, locked room. This makes them super lightweight and crazy fast to start up. We're talking seconds. They're just isolating the app, not the whole machine. And that is the magic.
Okay, so if a container is our final running application, how do we actually get there? Well, it's not magic. It all starts with a blueprint. And in the Docker universe, there are three key pieces to this puzzle. Let's think of it like this. You've got the recipe, the master plan, and then finally, the actual building. Step one is the Docker file. And really, don't overthink it. It's literally just a plain text file. It's a list of instructions, like a recipe you'd follow in the kitchen. You write things like, start with this basic ingredient. That's your base system. Then add my code. And now install all the things my code needs to run. It's the simple step-by-step guide for creating your app's perfect little home.
So what happens when you give that Docker file recipe to Docker? It follows the instructions and bakes an image. Think of the image as the finished, perfectly packaged kick mix. It's a read-only template that has everything bundled up inside. Your application, the code, the libraries, all of it. It's a frozen-in-time snapshot. You can't change it, but you can ship it anywhere, and that's the key. This is your master blueprint.
And that brings us to the main event, the container. A container is what you get when you actually run the image. If the image is the blueprint, the container is the house built from that blueprint. It's the live, breathing, running application, safely tucked away in its own isolated space. And the beautiful part is, you can spin up hundreds of identical containers from that one single image. They're the disposable, running copies of your master plan. All right, theory's over. We've got the concepts. Dockerfile is the recipe, image is the blueprint, container is the running app. Now, let's connect the dots and see how you actually go from a line of code to a fully running container.
So what's doing all the work behind the scenes? That's the Docker engine. You can think of it in two parts. There's the Docker client, that's you, typing commands like docker run into your terminal. Then there's the Docker daemon, which is like the hard-working engine room. It's a service running in the background that listens to your commands and does all the heavy lifting, building the images, starting the containers, managing everything.
And here's the workflow in a nutshell. It's a beautiful, simple, three-step dance. 1, you write your Docker file, your recipe. 2, you tell Docker to build it. That command reads your recipe and creates that portable image. And 3, you tell Docker to run that image, which instantly fires up a brand new container. That's it. Write, build, run. Over and over again. It's the heartbeat of working with Docker.
So this is great. We have our app running in its own perfect little isolated box, but you're probably asking two things right about now. First, how do I actually use the app if it's locked inside that box? And second, if these boxes are disposable, what happens to my data? Like if a user uploads a file, where does it go?
Let's tackle that first question, getting inside. The answer is something called port mapping. It's exactly like punching a window through the wall of that isolated container. You're basically saying, hey Docker, see this little door inside my container? I want you to connect it to this other door on my main computer. This creates a tunnel so traffic from the outside world can get to your application. And you won't believe how easy it is. When you run your container, you just add a little flag, P. The format is always the port on my computer followed by the port inside the container. So this example here, P8080 to 80, means
any web traffic that comes to port 8080 on my machine, I want you to send it straight to port 80 inside the container. That's all there is to it.
Okay, now for that second super important question about data. Here's a critical thing to understand. Containers are designed to be thrown away. They're ephemeral. That's a feature. But it means that anything you create inside a container's file system, a database, a log file, a photo someone uploaded, it vanishes into thin air the second you delete that container. Poof, gone. So obviously, we need a way to save our important stuff somewhere safe, outside of this disposable box. And for that, we have two main tools, volumes and bind mounts. Think of a volume as a special managed backpack that Docker gives to your container. Docker handles where this backpack is stored and makes sure the data is safe, even if the container is gone. This is what you want for things like databases, your production data. A bind mount is different. It's more like a direct pipeline. You're telling Docker, hey, see this specific folder on my computer? I want you to mount it directly inside the container. This is amazing for development because you can change your code on your machine and poof, the changes are live inside the container instantly. Okay, so we've mastered the art of running one container. But let's be real. Almost no modern application is just one thing. You've got your website in one container, your server logic in another, and your database chugging away in a third. They all need to talk to each other. So we're graduating from managing a single building to becoming the city planner for an entire application ecosystem. And our city planning tool is called Docker Compose. It's brilliant. You create one simple configuration file, it's called dockercompose.yaml, and in it, you lay out your entire city. You say, okay, I need a web server service, a database service, and an API service. They need to be on this network, and the database needs this specific data volume. It's your entire application architecture written down in one place. Then you just type one command, and Docker Compose builds and runs the whole city for you. But what if your city gets so popular it needs to expand across multiple physical machines, or even multiple continents? A single city planner isn't enough. You need a government. That's orchestration. Docker has its own version called Swarm, but the undisputed king of this world is Kubernetes. Think of Kubernetes as the automated brain that manages everything at a massive scale. It decides where to run containers, scales them up when traffic spikes, and even automatically replaces them if they crash. It's the next level.
Wow, we have covered a ton. So to bring it all home, let's wrap up with a few quick-fire pro tips. These are the things you'll want to keep in mind to build really good, really efficient, and most importantly, really secure containers.
First up, image size. Smaller is always better. Why? They're faster to download, and they have fewer things that could possibly go wrong. So always try to start with a tiny base image, something like Alpine. Use what's called a multi-stage build, which is a clever way to throw away all the tools you used for building so they don't end up in your final image. And try to chain your commands together. Every command creates a layer, and fewer layers mean a leaner image. Next, and this is a big one, security. Please, please, please do not run your containers as the root superuser. It's just asking for trouble if something goes wrong. Second, never, and I mean never, put secrets like passwords or API keys directly into your Docker file. That's like taping your house key to your front door. And finally, get into the habit of scanning your images. Tools like Docker Scan can automatically check for known security holes before you ever deploy. So if you forget everything else, just remember this one thing. The entire point of Docker is to take your application with all of its messy dependencies and configurations and lock it all up in a standardized box that will run exactly the same on your laptop, on your coworker's laptop, on the test server, and in production. It kills the works on my machine problem for good. And that kind of leads to a final thought to leave you with. Containers completely changed the game, right? But now they're getting even smaller, even faster, and they're blending with other tech like serverless platforms. So it really makes you think, what's the next huge leap? What's going to change how we all build software in the next 5 or 10 years? Something to chew on. Thanks for hanging out and digging into this with me.